Hello and welcome to the first of the advanced deep dives. So these are going to be much lengthier ones, and certainly at the beginning, I don't actually know if this is going to be the first part of this one or if we'll be able to cover it all in the entire one. My gut feel tells me that this one is probably going to end up being actually two parts, but if it is, they'll be bundled. There are separate ones that will be linked together. So the goal with these advanced deep dives is they're going to pick really sort of meaty, substantial areas, and we're going to be diving into those. So these are assuming a lot of starting knowledge. These are assuming that you are very comfortable writing stuff in code, working with the editor, customizing the inspector, things like that. So it's assuming a pretty high level of comfort with areas. But that said, I'm still going to be, as we go through these, talking through the steps, the processes there, and outlining and explaining the different bits as we go through. As always, the full code for these is going to be available with the link in the description. And this time around, what we're going to be taking a look at is procedural generation of a terrain. Now, there's a lot of different methods for doing this, and there's a lot of really cool resources out there. I'm showing a way of doing it. I want to be very clear that this is a way of doing it, not the one definitive method. And you will be able to find a lot of other methods that folks have used out there. So, have a look at a range of different methods. Which ones you want to use are going to really depend upon the effects you're trying to go for, the type of project, things like that. So it's not a one-size-fits-all. So this is going to be a method. Hopefully it's something that's helpful that you can apply potentially to your own projects. But as I said, there's a lot of other cool methods out there as well that absolutely make sure you check them out because they are awesome. So with that, time for me to retreat down to my corner. So starting point is I need to give a shout out to the sort of basis for the foundations for what I'm making here. So we're going to be having terrain generation where we're going to be setting up different biomes. And the process that I'm going to use for spawning those biomes is based off of this article, which I will also link in the description below, from Pat Scott on Biome Generation for ProcJam. And this is really cool, really great article, really well explained how they walk through it. The visualizations really help there with that process as well. So link is going to be in the description below. Please do check this out. It's excellent. And it's an ooze-based method of generating biomes. And as we can see in their really cool animation here, the biomes just spread out. They ooze out. It's really cool. So this is a method I found at the beginning of the year, and that I have made use of that for the particular project. So that's what we're going to be setting up and getting up and running here. All right, so let's get started and think about how we want to approach this. And that's going to be a hallmark of these advanced deep dives, that a big chunk of it, I want to be talking through my thought process. I want to be talking through the kinds of decisions that I'm making, the things that I'm considering and weighing up, just to try and give a bit of an insight into my development process of how I go about this. Again, I'm not saying that this is the one and only development process. It's definitely not. I'm also not trying to say that it's the best development process, because there's other processes there that are going to be better or a better fit for you. This is what my process is for this. So general sort of starting point I would use for something like this is I'm actually going to create a Unity terrain, because we will actually be working with the Unity terrain setups. And so with this, one of the things I'm going to customize to begin with is, because this initial world is a reasonable size, so it's 1,000 by 1,000. And we could keep that size. If I pull the camera out, yeah, that kind of feels an okay size. I'm okay with it being 1000 by 1000. So we want to key stuff off of this. We want to be being able to spawn different biomes in here. We want to be able to be adjusting the height of them. We want to be able to be texturing them. So we want to have all of those little bits and pieces up and running for this. So I'm going to update the name here. This is one of my pet peeves with terrain, that it just creates the things called new terrain. I'm going to relocate it so it's there next to the scene. And so we've got that nicely located. So if we think about how we want this to work, because there's different ways we could do procedural generation. We could do runtime procedural generation, where at the beginning there's nothing and then we hit go and it generates. Or we can do editor time style procedural generation. Either approach is fine, depends upon what you're after. Obviously, runtime procedural generation means that it can be a bit more challenging for performance optimizations, because you don't have that same ability to have slow processes run that pre-generate a lot of data that you might be using at runtime. But that's okay. We'll be able to get this up and running. So I'm going to create a folder for my scripts. The thing about this, I do want to go for the approach of having it be editor side generated. And I want to have the configuration for this not be embedded in the level. I want it to be easy for me to take that configuration and apply it to any other level if I wanted to easily reuse things. And so I want that data to sit outside of the level. I try and avoid having too much of what we'd consider just general data sitting inside the level, because that's something that then creates potential for merge conflicts, things like that. It makes it more difficult if you've got multiple people needing to work on the same set of data. So I like to split data out. So this is a good case of where I would be making use of scriptable objects. So if we think about it, I want to have a general scriptable object that is controlling the actual terrain generation. So what I'm going to have is I'm going to have my procgen, and I'm going to call this like my procgen config SO. Now, this is a stylistic thing from my point of view of putting SO at the end of class names when they're for a scriptable object. It's purely stylistic, so that I just have something that clues me in as, yep, this is a thing that's different. So I've got my configuration for the procgen. I also want to have my biomes as a scriptable object. So that again, the biomes can be something that I could have multiple sets of procedural generation, and I could also have biomes that might be shared between them. I'm also going to set up a procgen manager. And again, I'm going to set up a separate script for that. So the idea is going to be that the procgen manager does all of the heavy lifting. So it will do all of the heavy lifting of working with stuff, and my individual scriptable objects provide purely just configuration data for that. So let's make sure I've got my procgen management script on there. So that's cool. All right, so let's make my scriptable objects so they actually can do something. So if you have Microscriptable Objects, they're a class that you can set up so that we can store data. They're essentially an asset. So we get rid of our start and update functions from them. They don't have a start or update. And rather than inheriting from mono behavior, they inherit from a scriptable object. To have them be something that can be created, we add in this attribute create asset menu. We can set the default file name. So in this case, I'm going to call this Biome Config with a space in there because we can. I can set the menu name. Now with the menu, if I do something like this, a procedural generation slash, that means it'll create a submenu called procedural generation. And then under that, I will be able to have particular things. So I can have biome configuration. And then I can mess with the order if I wish. So I'm going to set up that. I'm going to have my procedural generation config. This will be my procgen config. Procgen configuration. Okay, so let's start to think about the different things. Well, my procedural generation config, for certain, it needs access to those biomes. So I'm going to have a serialize field. Actually, no, because I don't want. Normally, I would go for serialize field if it's something that I want to configure it in the inspector, but I'm not accessing it outside of things. But in this case, I know that I'm going to need to access it outside of it. So let's have a biome configuration. And this is going to be my list of biomes. Now, biomes, I might want to have them have a weighting or a priority. And I might not actually want that baked into the biome itself. So this is a case where what I would often do is I would create a little class here that is, I'll call it, say, something like a biome config. And let's give this link to the biome and a weighting. And we're going to just default it to 1. I'm going to make this a ranged 1 though, so it can go from 0 to 1. We've got a nice slider for configuring it. And I need to make sure that this is marked as serialize field. Because what that's going to let me do is it means my weighting for a biome is able to be configured separate to the biome itself, which is just going to work a lot nicer for, it means that the data that's in the biome is only the data that needs to be. Cool. So this, if we think about what stuff I might need here, there is going to be a whole bunch of things I do need. But for now, I'm just going to set up the name. So I want the biomes to be able to have a name that I can potentially refer to. So that looks all right. I've got my set of biomes. I've got my ability to configure the names. That's enough for me to start to set up the data. So my dev process usually for a lot of this stuff is I alternate between getting a little bit set up so I can start to create the data for things. And then I start to think about how do I want to use it? And that's usually the context that I come at these things from of, okay, I know I'm going to need this, but how am I going to use it? What does that information actually, look like? What do I want to be getting effect-wise? And I kind of try and build from effect back to what is the logic that I need. So let's start to set up, and we can see under create, we have procedural generation now. So I can start to set up my biomes. So I'm going to prefix these with biomes just for ease of searching. So let's think of some biomes that we could have. So given that I'm in Australia, let's go for some quintessentially Australian ones. So we're going to have scrub. I'm going to also have bush in there, which I would, and this might be a contentious point, I would consider scrub different to bush. I would consider scrub to be something that is far more sparsely sort of populated in terms of vegetation, things like of that, whereas bush I would consider a bit more densely vegetated, so taller trees, things like of that. I would then also, again, differentiate with rainforest, where we were talking something where it's quite dense, it's very, very green. Both bush and scrub would be sort of more drier environments there. So we'll have bush, rainforest, scrub, and and let's also have just general sort of grassy plains areas. So that's a good mix of ones. I'll get the names set up for these. That's good. We'll have our rainforest. And we'll have our scrub. So we've got our biomes. I can then create my configuration for the procgen itself. That looks good. So my procgen config, that's looking, oops, that shouldn't have been serialized field. That should have been system serializable. I was wondering why it wasn't showing up. Now it will actually appear. And we'll be able to, there we go. So we can configure our 4 biomes. This just makes for a nicer way of configuring it. So we're splitting the data out of the scriptable objects if it doesn't specifically need to be in it. So I'm a big believer in this, of trying to make sure we're storing the data or the logic in the places that make sort of sense. Okay, so we're going to say rainforest is a fairly low weighting. But we're going to make bush and scrub be fairly high weighting, and grassy plains also a fairly low weighting. And I think actually lower than the rainforest one in this case. So these don't need to add up to 1 or any particular value, because what we will do is we will actually normalize these when we go to use them. So we don't need them to have a specific value at this point, because we'll come through and we'll normalize those when we get to working with them. So, okay, we've got our rough setup. We know the particular biomes. We have our setup for the manager here. So this is one where I would use serialize field. And that's going to link to the config. So that's good. Got that linked to the config, and we can connect that up. So then we can actually start to think about the generation, because this is also going to need to link to the terrain. So I'm also going to set up a link here for the target terrain, just so it knows which one to be modifying. And then we'll be able to start thinking about that modification. So how the terrains work is they generate, well, they have effectively textures that control things like the height. So the height is a grayscale texture called a height map. And we can actually control the resolution of that height map. And we can see the settings here. So height map resolution of 513 by 513. That means that there is a 513 by 513 pixel texture that is controlling the height of each vertex. That's why it's an odd number of ones, because we have an odd number of vertices there. And so we can change the size of that, because at the moment, with a texture, or with a terrain that's 1000 by 1000, what that means is every pixel effectively is controlling a square that's about 2 by 2 meters. So if we went to a larger one, then that means each pixel is controlling an area that's about 1 by 1 meter. And that is generally going to give us a bit more control, a bit more ability to have this be working the way we need. So, okay, that's a good sort of starting point with this. So now we need to start actually having this do some of that generation side of things. So that's going to be the next step. Is what I want to be able to do is in the procgen here, I want to be able to click on a button. I want to be able to click on a button that says generate terrain, and it actually goes through and does that process. So that's our next step, is a little bit of custom editor side scripting as well. All right, so to create that button, it means we need an editor script. So for setting up an editor script, important thing is we need a folder called editor. So any scripts that are only running in the editor, they have to be in this separate editor folder, because scripts inside editor are excluded when you are doing a build, and because our editor side scripts can access things that we actually can't normally access when we're actually running something. Whoops, and that's... Oh, don't compile that yet. Yes, I want you to delete that. So we need to make sure our editor scripts are firstly properly named and also are in a separate editor folder. So I'm going to have my ProcGen Manager editor. That should make sure it's all good. Excellent. So it's in the editor folder, which is good. So this, I actually want to say this inherits from editor. I want to chuck in a using Unity editor here. And then what I typically would do is we don't have start and update. But what we want to say is that this is a custom editor, and that it is a custom editor for the ProcGen Manager. So that way then Unity knows this is the class to use for when we are working with the editor. So then to customize that inspector, we have our onInspector GUI. Then the first thing we need to do is, because I don't actually want to mess with what we're actually showing normally, I'm just going to tell it to draw the default inspector. I'm just adding in a button. I want all of the rest of the stuff to still happen. So then what I can do is just add in a button here, regenerate world. Let's go with that. So this is the way, if you haven't seen editor code before, this is the way it tends to be written. So this line draws the button, and if the button has been clicked on, it will then run the block here. So it's actually doing both. Something tends to be referred to as immediate mode GUI. It is a very different way of working, and it can easily be very confusing, but it is something you do get used to, and I do actually really quite enjoy it. So this is my target manager. So to retrieve this, we have this variable that we can always access here. It's my serialized object. And then I can say the target object as the ProcGen Manager. And autocomplete is still catching up. But then I can say, hey, target manager, regenerate world. Because then I can come over to my ProcGen Manager and set up a function here, void regenerate world, which needs to be public. Now, a key thing I want to do with this is, because this is going to have a whole bunch of logic that doesn't need to be there at runtime. So I'm going to explicitly make certain that this code only runs in the editor. So we can use preprocessors like this, the #f. Unity editor is only defined for code that is running within the editor window. If we created a build, this is then excluded from it. So it means we're not bringing in extra code that's not being needed, and it also forces us to make a bit of a partitioning between what is editor side code and what is game side code. So this should mean that our ProcGen Manager now has a button on it. Regenerate world, which at the moment does nothing, but that's okay. It doesn't need to yet. So, okay, we've got our biomes configured. We know that we are going to need to then start working with some of this data. And our starting point is we need to generate these biomes. So the sequence is we generate where biomes are applied. Then within those areas, we can do texturing, and we can do terrain manipulation, and we can do object spawning. So starting point is that ooze-based generation of stuff. So in order to do that, we need to know the kind of size of area that we're working with. So we can ask our target terrain for that information, because we're going to initially key everything off of the height map resolution. So our target terrain has this thing called terrain data. And terrain data, we can actually access our height map resolution. So that's something that is super handy to be just caching out. So this is going to be our map resolution. I'm just caching that. So cache the map resolution. And then, okay, let's key off our biome generation. So our biomes, if we think about the information we need to store. So we need to be able to store what biome is applied at an area. Well, our biomes are stored in a list, so we could easily look them up by index. That's a workable option there. So we could use an integer for that. We might need to store the weight of our biome, so that's a useful thing as well. So let's set up a couple of things in a moment, and I'm going to also put these in the editor, because these are not things that we need outside of the editor side of things running. So I want to store the particular biome at a location. So I could use an integer for that. I could also use a byte, because I'm not going to be, a byte would allow me to have 256 different biomes. And I think I would be hard pressed to come up with 256 meaningfully distinct biomes. So I'm going to say that this is a 2D array. And this is going to be my biome map. So that's going to store what biome is applied at a location. I'm going to then have another map that is the biome strengths. So that's going to be for a given location. It's going to store how strong a biome is. So I'm going to then set up here a perform biome generation. So I want to split these things up into multiple functions, just because keeping it so that it's a little bit neater. But that biome map generation, I'm going to feed in the map resolution, because the first thing I want to do is allocate the biome map and strength map. So biome map is a new byte, and it is map resolution by map resolution. Biome strengths is a new float, and it is map resolution by map resolution. Cool, okay. So we've allocated those. Now we need to work out how many biomes to actually spawn. So that's something where in the Procgen config, that's probably a good thing there of having, because we know how many essentially potential points we've got, because that's keyed off of our high map resolution. So in our case, we would have 1025 by 1025. So a bit over 1 million potential points there. Now, obviously, we don't need to spawn one at every single point because these things spread out. So we need kind of a control for the density there. This is one where I would usually go for, I think, a percentage-based one, because I think a percentage base is going to work well for keying off between different sizes of maps. I feel like if I set a hard number threshold, that's going to end up, if I change the size of the map, I'm likely going to just be setting it based on a percentage-based thing anyway. So this would be one where biome seed density or seed point density. So I'm going to say that seed point density, let's start it at 20%. Actually, no, let's start it at 10%. And it's again going to be a ranged one. Cool. So that's the number of seed points I'll have. So, okay. Got the number of seed points, because the way the ooze-based approach works is we pick a starting point and then we spread out from it. So that starting point is our seed points. So we've got our seed point, we'll have our seed points, we know the number of ones we need, and we know our biomes have a different weighting. So the higher the weighting of a biome, the more seed points it should get. Now, there's different ways we could go about ensuring that. Well, sorry, the different ways we could go about attempting to do that. We could do random rolls and just check different thresholds. So, okay, if it's below this amount, then it becomes this biome, and those bands are essentially set just directly based upon the weightings there. But randomness gets streaks, which means we could easily have that be distorting the number of biomes, and that could actually throw things out of whack. What we could do, however, is we know exactly how many points we need to have. So we could make sure that we always spawn a certain number of one biome, a certain number of another, a certain number of another. Now, we don't necessarily want to do those biomes in a hard fixed order either. We still need randomness in there, because if we always applied the biomes in the same order, then whichever biomes are applied last are going to tend to stomp over the other ones. So we still need to randomly pick which biome we're spawning at a point in time, but we need that picking to be from a set where it doesn't matter that it's picking randomly, it will still give the distribution we need. So a good way of doing that is we can actually fill up a list with, okay, here are the set of biomes to spawn. So we would have something where, for example, what we could do is I would use a list, and I would say it's a list of biomes to spawn, and that's a new list of bytes, and I can pre-allocate the amount that I need here. So what I can say is a mathf, and I want to, let's go for a round to int. Actually, it'll automatically clamp down. So let's go floor to int of map resolution by map resolution times my config biome seed point density. So this is the number of ones to spawn, and I'm going to actually put this into a separate variable. Num seed points. Is this? So set up space for the seed points. So now I need to actually fill that. And what I want to fill that with is, the index of the biome, so the position of it in here. So these weightings, I kind of need to normalize those because this as a weighting is fine, but I need to actually know what proportion it has to be. So first thing I want to do is calculate the total weighting. Get the sum of all weightings, because that would allow me to normalize it. This would be something where I would often do things like setting up a property for this. Float, total weighting, because what this can do, and I just, it doesn't have to be a property, but I kind of like this approach as just an easy way of sort of keeping the rest of the code clean. Because I could calculate it in the ProcGen manager, but it's something that the ProcGen config has this data, so it might as well do that calculation. So all I need to do is for each config in biomes, sum, and we'll add in the weighting. Cool. So that works. I'm also, while I'm here, going to chuck in num biomes that, well, actually I can do the easier setup for this. It's just going to be biomes count. Just so again, I've got an easy way of knowing where I need to fill up to. So okay, I know my total number of biomes, I know the number of seed points that I need, I know the weightings, which means I can start popping values into here. So what I would do is populate the biomes to spawn based on weightings. So what I would say is for, and I'm using a for loop with integers because I need the actual index. So in this case, I could use a byte if I wanted to, but biome index 0, biome index is less than our config num seed points, num biomes. That's better. Plus biome index. So what I want to do is work out num entries, or num entries. It's fine. So what this is going to be is my config. So that biome, I get its weighting and I divide it by the total weighting. So I'm going to store weighting is total weighting. So this is going to normalize it. It means that this version that I'm going to have, so total biome weighting, because I said those biome weightings don't need to add up to 1. But if I do this maths and add that for each of the biomes, that will add up to 1. And that's the key thing. I'm normalizing these probabilities, or normalizing the weightings. So that's the number of seed points that I will have. So mathf, and I'm going to use a round to int, which means it might go up a little bit. It's fine. That'll be the number of entries. I'm going to have a debug log in here. Will spawn num entries seed points and then we can just display the biome's name. Biome. Cool. So that will tell us the number of entries there, and then we just add in those entries. So we can go for the very low-tech approach. Entry index 0, entry index is less than num entries. Add to that. And then all we end up doing is biomes to spawn. We add in biome index, which we need to cast to a byte. So all we're doing is we're filling up a list. That list is going to have all of the seed points, but it's going to have, and we'll see once we are able to run regenerate world, it'll tell us how many it's going to put there. So you can see, based upon the weightings, there'll be about 37,000 seed points for the bush, 11,000 for grassy plains, 18,000 for rainforest, and 37,000 for scrubland. So that then we can start to use for actually doing the particular spawning, because then what we do is we start performing the actual spawning. Spawn the individual biomes. So while biomes to spawn count is greater than 0, we pick a random biome. Seed point index is going to be a random number from 0 to biomes to spawn.count. So we're picking random seed point. So then we can grab the actual biome that is going to be. So we would say perform spawn individual biome. And then what we can say is our map resolution is potentially going to be a handy thing to pass in as well. But a main thing that we need to actually be saying is what that index of the biome is. So I'm going to store that in a separate variable. Extract the biome index. So biome index is biomes to spawn, seed point index, and that's what I will pass in here as the biome index. And remove seed point. So we can't pick it again. So we then biomes to spawn, remove that, biome index. So that's good. And then we'll have a function here that is perform spawn individual biome. We have our biome index. I'm also going to pass in the map resolution just because it saves me having to retrieve it from things. But what we're doing is we are filling out this seed point list with the type of biome to spawn, and we're filling that out based upon the weighting. That allows us to make sure that we have that tight control over what number of ones are spawning, but then we're picking randomly from that. So we're not making it that biomes then have an implicit priority based upon what order they've been put in the list. We're still picking them randomly, but we know that we will have a controllable number of them. So this is a way of being able to use randomness, but have the randomness have a level of control over it, so that we've got that behavior there a little bit more wrangled. And now we can make it do the actual spawning of the particular biome, so starting to do that ooze-based approach. So we're ready to start spawning the biomes. So we have our type of biome to spawn. We need to pick the location to spawn at. So that's a next starting point and this is where I'd make use of vector2int. If you haven't already seen this, vector2int is a thing. So spawn location, and that is going to be a new vector2int. And so that is going to be random range from 0 up to the map resolution, and the same in both. 0 to map resolution. Now this is something where if we wanted to, we could actually introduce a bit of a bias here, where a biome might have particular ranges that it's allowed to spawn in. And that would allow us to do things where, okay, well, this type of biome is going to be more clustered in the southern section of the map, or the northern, or the central area. That's something we could absolutely do for managing to get that effect, and that could be really cool. So again, there's a lot of different layers of things that we can be doing with this. There's not one hard and fast way of this is how you must approach biome generation or procedural generation. There's a lot of different ways of how we can actually go about it. So we've got our location. Now, the fundamental approach with these ooze-based ones is we pick a spot, we start there, and then we spread out. Now, how far we spread out is determined based upon our starting intensity. So the biome, we need a way to have the biome have a intensity. So this is something where I would probably have, again, a ranged float, a min intensity, and I'm just going to make it the same for all biomes. The effect this is going to have is the higher these intensities are, the more a biome is going to be able to spread typically. So we want to have our min intensity. We're going to have a max intensity. And that, we might say that can be up to, let's say up to 1. So we've got a fairly large range there. So the intensities will control that starting point. We then also have, the idea is each step away from that starting point that we decay. So we could control the decay rate as well. So again, range floats here, and we could have a min decay rate. And that, if we think about it, this is the amount per square away. So whatever we set this to is kind of in combination with the intensity, setting the potential range of this. So the lower the decay rate, the more it's going to potentially be able to spread out. So if and we've got a map that's 1,000 by 1,000. So we should keep that in mind, that we probably want fairly low decay rates. So I'm going to say the min decay rate is actually 0.1. So if we got max intensity and a decay rate of 0.01, then it could spread 100 cells. I'm going to then also say we have a max decay rate. And the max decay rate, I'm going to say, is 0.02. So, okay, we have our intensity. So that's something we need to pick to start with. I'm also going to cache the biome config here as well. So the biome config, I'm going to cache that. Just because, again, like I'm a big believer in caching information like this. It tends to make life a lot easier. So pick spawn, cache biome config. Now this is a bit more commenting than I'd often normally go for, but because I want this to be really clear what's happening, I'm going to be making sure I'm commenting fairly regularly throughout. So okay, we've grabbed the biome, we've picked the spawn location. We need to pick our starting intensity. So this is essentially the amount of ooze we are dropping down onto the location. Pick the starting intensity. And I am also particular going to bring a comment in here because credit where credit is due. Use based generation from here. Really important thing. Always make sure you're giving credit for things that have been an assist. It's really important. So, this was a huge help. I would not have come up with this method on my own. So please do make sure that you're including credit for this if you use this approach. Be nice if you throw in a credit for me if they've used stuff from the video, but really, this person, please do credit them because their thing is very cool. And this is only really something I'm able to be doing because I read their article and it was super cool. And it's such a great idea. So, starting intensity. It's going to be random range, and it's going to be from Biome Config, min intensity to Biome Config max intensity. So I've got my starting intensity, I've got my start location, all good so far. Now I need to actually start changing the particular things. And so I've got different ways of how I can go about doing this, but because what's going to happen is we have a starting point, we fill that one with that biome, then we expand out. So now we have multiple other points we need to expand from. And as we go further and further out, we'll have more and more ones that we need to expand from. So what I want to do is I want to actually have, this is where I use an approach of maintaining a working list of stuff to be processing. So I'd have a list vector2ints, and this is my working list or to process, points to process. I'm just going to call it working list, shorter. So that's a new list of vector2ints. And the first thing I do is I just actually add that one in. I add in my spawn location. So I'm setting up my working list. So that's cool. And then let the oozing begin. Not the most nice description, but it's accurate. So what I want to do is, as long as working list has things in it, I'm going to be doing some work. So the first thing I'm going to do is I'm going to remove the location. Working location, it's working list 0. And I could use something actually like a queue for this. This could be, yeah, actually, you know what? I'm going to use a queue. Don't often use them. This is a perfect example for where we would be able to use something like that. Because then I would say working location is working list dot dequeue, which will remove the item and also then grab it. And because a queue is first in, first out. So I've grabbed the location. So if we think about what I need to do, I've grabbed the location. So I need to set the biome at that particular point to the this new biome. So what I would be doing is, because I've got my biome maps, so I'd be saying biome map working location dot x working location dot y is equal to biome index. So I've set my biome, which is good. I'm going to make that a byte because that'll just make the process here a little bit easier. I could probably convert these to bytes, I reckon. Might just actually do, oh, that's easily done. Cool. So I can set the biome, and then what I want to do is add in the potential neighbors. So we've got a grid, which means I have 8 potential neighbors around me. Now, when I'm working with stuff like this is where I will often go and do something like this, where I'll set up an array of vector2ints of neighbor offsets. Because what that lets me do is I can say that is a new vector2int, and then I can actually give it the particular values. Gives me something that I can then easily iterate over. Because what I can say is, well, okay, well, one's going to be a new vector2int, and its offset is going to be, let's go for 0 and 1. So I like doing this approach because it just makes it easier for working with this stuff. So now I'm going to have 0 and 1, 0 and minus 1. And I'm going to have minus 1, 1 minus 1, with that being 0. So we've got those 4, and I'm going to have 4 more 1s. So now I'm going to have 1, 1, I'm going to have minus 1, minus 1. I'm going to have 1 and minus 1, and I'm going to have that. So that gives me all of the possible combinations that I might have. So our neighbors above us, below us, to the left, to the right, up and to the right, below and to the left, below and to the right, and below and to the right, and above and to the left. So we've got all of the possible options. So what that lets me do here is traverse the neighbors. So for, and this is, I could use a for each, but I'm going to be reiterating this so many times. I think a for is a better option. Neighbor index 0. Neighbor index is less than neighbor offsets length. Add the neighbor index. So then we have my neighbor x is going to be my spawn location. Actually, sorry, I can just do vector2int neighbor location is equal to my working location plus that neighbor offset. And I can then check that that neighbor location is valid. So skip if invalid. So if neighbor location x is less than 0, or neighbor location y is less than 0, if neighbor location x is greater than or equal to map resolution, or the same with y. It's a lot of different ones we need to check. So map resolution, then we skip. So, okay, we're visiting our neighbors. Now, we do know that we will encounter a neighbor multiple times. And if we've already processed a neighbor, we don't want to process them again. So we actually need to keep track of what areas we have visited. So set up the visited map. So it's going to be a Boolean visited map. Actually, just called visited. So that's going to be new bool map resolution by map resolution. We want to mark our, actually, as we remove stuff from here, visited working location X. Oops, not that. Working location Y. It's true, so we mark it as visited. And then down here, skip F visited. So F visited neighbor location X, neighbor location Y. Then we skip. So now we know we are adding in things that are based on our neighbors. Well, we hopefully will be, because what I would be then doing here is I would be able to say my working list enqueue neighbor location. So that works. We enqueue in the neighbor location, and all right, so we know we will be able to process all of the particular neighbors. We know we're flagging that we have visited particular things. That's good so far. So far, so good. Now, at the moment, we're not including any decaying. We're not including any intensity stuff there. So that's a thing we need to actually make sure we've got, that we are factoring in the intensity for particular locations. So, because that intensity decaying is how we control the range that this goes. That's going to be the next step to get going in here, is having that decaying so that we can actually have the generation stop at a particular point. Okay, so the intensity is this next bit, because we need that to decay. And we need that to decay the further out we move. So it means that when we add in a neighbor, we're kind of needing to pick intensities at that point. So what we could do is visited map and target intensity map. So we could say float target intensity is our new set of floats. So we've got that, and we would need to set the starting intensity. So that's where our target intensity here is going to be, we use our spawn locations X, spawn locations Y, and that's our start intensity. So that's good. So we've got our target intensity there. We can then our biome strengths, working location X and working location Y. That's going to be our target intensity and at that same location. So I'm going to copy and paste. So that's good. We've got our strengths coming through, which is great. Now we need to look at decaying the strength for these. So work out neighbor strength. So that's going to be our strength of the working location. So neighbor strength is going to be our base one minus, and we need to get our decay. So from our biome, min decay versus our max, because then what we do is if the neighbor strength is less than 0, then we exit. We don't actually write data in for this biome. Now, we would have a choice here of, we could flag this as visited, and I'm inclined to say we do flag it as visited. The reason being is that what that will do is it'll allow us to effectively have holes occur in the biomes, which I think that is really important. It allows the biomes to be a little bit more patchy. So I'm going to actually say that that location has been visited. So if the strength is too low, flag as visited. And actually, no, we actually want to flag it as visited no matter what, as soon as we've checked it. Because even if otherwise, we entirely want to have it removed, because otherwise we could add it multiple times. So it's missing that because, yeah, we could enqueue the same location multiple times otherwise, which we don't want to do. Strength is too low. Stop. See, this ends up being a dead end. It can't progress any further. So that should then mean we're writing in the Biome Map, we're populating our working list. This should probably do the trick. So this is something where, we're not going to see anything, but what we want to check is that it runs and it doesn't crash on us. So there is a big potential that we could run this and it will hit an infinite loop. So this is probably a good point to make sure I'm all set up for debugging, just in case I need to deal with an infinite loop. I'm going to switch to debug mode because it does have issues to avoid having to terminate Unity. But let's see how we go with this. So we've got that there. Let's do regenerate world. Now it isn't going to be a fast process because there is a lot of stuff that is actually happening. And certainly I possibly should have done a little bit of testing earlier because it is going to sit there for a bit. But this is something where we can see how we can inspect this and just make sure that we have attached and we can find out where we might be getting stalled. So let's take a look and see. Our working list actually is a pretty reasonable size. We can check, we're already up to Biome Index, we've got Biome Index 3. We can go back up to here where we're spawning all of the biomes, because it could be a case that we have so many biomes to be spawning. And, you know, we do. The number of biomes that we were trying to spawn, it is 100,000, which is an awful lot. That is something where that number of biomes, we probably want to scale that back down. But this is a convenient chance to illustrate a way of dealing with scenarios like this, where we have an infinite loop effect, not entirely an infinite loop, but where we have code that is running for a very long time. So if you can catch it in the debugger, and if you've got something like this where you're accessing an array, then we have a way around this. All we need to do is we set that index in the array that it's trying to access to something invalid. Because what will happen is it hits an exception. And as soon as it hits an exception, it stops. So handy little trick if you have infinite loops like that. So what I'm going to do is my seed point density here is really, really high. I'm actually initially going to drop the terrain height map resolution. That will, if by halving the resolution, we're quartering the number of points. So that will speed up that process. So I'm going to, I didn't need to play. Why did I hit play? So that we can just make sure that runs. We will see some ways of how we can handle it with the larger number of ones. At the moment, our focus is really just on having it actually do the particular setup that we need. So in this case, we've got 500 by 500, and we've still got about 10% of the entries. So that's looking promising. So that one was, I think, not from that. That was a previous one already there. I think. I'm pretty sure that they're less than the size of the collection. Let me just double check. We remove it. Oh, that would help. That was very silly of me. Okay, but we should be generating our particular biomes now. But we can't really see that at the moment. So what we can actually do is we can generate a texture from these, and this can be a really handy way to output what the stuff looks like. So I'm going to set up a texture 2D Biome Map. Sets a new texture 2D. It's map resolution by map resolution. The format is, we want RGB 24, and we don't want bitmaps. So what I want to do is, from the biome index, I'm going to turn that into a particular color, and we're going to write that into this. So I'm going to loop through y0, y is less than that resolution, name an x is less than that resolution, because I can then say biome map set pixel x and y, and I can give it a color, which what I'm going to do for generating the colors is I'm going to cheat and use HSV to RGB. We'll see why in a moment. I'm just initially going to set the hue to that, separation, and brightness. Because what we can do is we can take advantage of the fact that the biome numbers go from 0 up to a fixed value that we know, and we can use that and convert that to the hue. Because if I access Biome Map at x, y, and I divide that by my config num biomes. And although I only need to convert one of these to a float, I kind of like to convert both. That is going to give me a value that is from 0 up to, it won't actually hit 1, but it will give me a value that no matter how many biomes I set, I will end up with distinct colors for each one, which is really handy. So I can generate this texture, I can apply it, and then I can save it. So I can just say system IO file write all bytes Biome Map.png and Biome Map encode to PNG. And this will save out an image into our project that we'll be able to take a look at. So we just want to confirm that we're seeing data, really. So we'll let it regenerate. This time it won't be hitting that exception because I'm removing a thing that doesn't exist. And we'll see what this looks like. Because we haven't really customized any of the settings, things like that yet. That's absolutely something that we could do. But we'll see. And where did it put that file? Show in Explorer. So there we go. Biome Map PNG. Moment of truth. So super dense in terms of it's really high resolution what it's actually created. So I reckon we can make some changes to this. So what we could do is, and again, my terrain, I'm going to intentionally just drop the detail of the terrain, just so it generates faster. It's not really going to affect the process for the generation, it'll just mean it drops faster. So we can then add that's looking not too bad, but we're not really getting the behavior that we want there. We've got a lot of stuff that's, you know, the default biome, but not a lot of stuff that's sort of forming larger clumps. So we can start to take a look and see why that might be. So we worked out the neighbor strength, but we forgot something. Because we checked it, but we didn't store it anywhere. So what we need to do is target intensity. Once we've calculated the neighbor strength, then we do neighbor location X, neighbor location Y is equal to neighbor strength. Okay, and store. So easy to run into things like of this. This is part of the reason for display, outputting an image like of that, so we can test and see what's happening there. So let's regenerate that. That also means the generation is probably going to take a bit longer because now it actually is able to spread. Whereas before, it would have been ending very early. We've also, because we've really dropped the resolution, these are going to be running for way longer than we necessarily planned before. So our working lists are probably going to get much larger, we'll likely find. And we could be checking back up here, see how many biomes we've got left to spawn. So we've still got another couple of thousand. We were aiming to spawn 6,000. So it's about 2/3 of the way through. Again, this is a much slower thing than what we'd be able to do if this was happening at runtime. And we do have other approaches of what we could do for this, because I'm generating this fairly high resolution. And if we run this now, so that's looking a little bit nicer. It's very blocky though. But we do have these sort of chipped away edges, things like of that. So that's looking pretty cool. Like that is looking better than what it was looking. But we can actually do better than this. We can improve the process that's happening here. And what we can do is, rather than just using our actual intensity, because that's going to give very blocky ones. So one of the things is that decay that happens, we could scale that by our neighbor offset, so it's distance. Because at the moment, I'm going to store this separately, decay amount. Because at the moment, diagonals aren't getting treated differently. So we can fix that. So this is going to be decay amount. So now diagonals will actually have a larger cost. So that will work better. I'm also going to adjust the decay rates for these so that they are a bit larger. So rather than being that, I'm going to make 0.1 and 0.2, given that we've got much smaller environments. So I'm going to do that for all of these, just like this. So adding in diagonals will help. That'll mean that we won't get those sort of really squared off. The reason we're getting very squared off ones is because of those diagonals. So, okay, that works. Let's see what that looks like. And this isn't the only option we've got. Now, that was a lot quicker. You can see now these are a lot more irregular in shape, which is better. And we've got ones where there's a bit more sort of boundaries, things like that. So that looks pretty good. I'm pretty happy with how that's looking. But there's more we can do. So what we could do is we could also then add in some further randomness to this, where there is a chance where stuff could just actually randomly stop no matter what. So we could also then chuck in just we're just going to do a random roll from 0 to 1. And there's a couple of ways we could do this. If we say if that is less than the neighbor strength. So that's going to mean that the lower the strength is, the less likely it is to hit this condition and stop. But at really high strengths, it could end early. So we've got kind of an early interrupt. And we can see how that looks. And a big part of this is it's good to just experiment with different versions of what we could do here. Especially now that regeneration is quicker because we've got things tuned a bit better. So with that, things end up super patchy. So we have these little spots inside ones, probably not desirable. So we can see, okay, that's maybe not great. What if we flip the sign of that? So that it's actually a case of it's less likely to stop near the center of a point of ooze and more likely to stop towards the edge. So we can test with that. And as I said, a lot of this is about trying different things, seeing the sort of effects we get, and adjusting ones. So with that, it's still getting a bit more patchiness, and that's actually pretty patchy. So I think I'm just going to stick with if the strength goes below, that should actually be a less than or equal to. Because that was looking pretty good when we just had that sort of generation there for it. So we can see, that looks pretty good. Like I'm pretty happy with that. We could set up stuff to bias it based upon, as I said, sort of the locations, things like that. We probably don't really have enough biomes for that to be effective. We can start to increase the size of this though. So we can test at 512 by 512, because now that we've got the different tuning there, we're going to be able to have slightly larger setups. The other option we've got is when we generate this, we can generate a super low resolution version, and then we can upscale that. So that can be a way to have better performance there. Is my height map might be 1 resolution, and yeah, that looks all right. We've got those sort of patches. We could adjust the weightings a bit further. So what I'm going to do is I'm actually going to drop the resolution down here a lot, 65 by 65, and generate the world, just because that's super quick for testing. But that looks all right. Like, I'm pretty happy with that. And this is where it can sometimes be better generating a low resolution one and then upscaling it. And that's actually a thing we're going to end up doing. We're going to take this low resolution version and upscale so we can generate the biome map really quickly and then scale up from there. So this is going to be the end of part 1 of this. In the second part, we're going to take a look at the upscaling approach, and then we're going to start actually modifying the terrain, both in terms of the shape of the terrain and also in terms of the texturing of the terrain. Now, depending upon how long that goes, we might also look at spawning objects in there as well. If not, the spawning of objects, we'll be doing that in a third one, because obviously there's quite a lot in this. So our focus with this one has been on generating our biomes, and in particular, the end result is, and I realize this is not the most inspiring end result, but this is the way a lot of these big systems work. The fact that we're at this point where we've got a texture, and a texture that lets us see, yep, we've got some big blocks of, and even some connections there. There's some nice sort of distribution of these. We've got a texture at the end of this, but we've got a texture that we've generated in a way that we can add to this just by adding in further biomes. So I could just add in another biome here, and this is just going to be, what do I want to call this biome? I'm going to call this swamp, and update that. So just by adding in that additional one, we don't need to change any of the code. I can add in my swamp biome. I'm going to leave that as the weighting, and then I can regenerate. And I can then, my biome map now has an additional color in it. So although it's a whole bunch of setup stuff that we've done, and although the end result is a small image that's, multiple different colors, it's the infrastructure. We've set up some really solid infrastructure to then build from in the later stages, and infrastructure that's going to allow us to then in future ones really customize this and add and remove biomes, and we don't have to go and mess with the code. It's all configured in data, and all configured in data held outside the level. So the key things in terms of how we've been structuring this, we are using scriptable objects to house our data outside of the level, and their purpose is just to hold logic. The stuff that's sitting in the level is just links to those sets of data. And we've intentionally split things out. So we have this idea of a biome, and the Procgen config holds those biomes and the weightings, so we could have different environments use those same biomes, but with different weightings. So we're trying to keep information being stored where it needs to be. We are using an ooze-based generation approach from Pat Scott here. And so we pick seed points. So we need starting points where we pick we grab a whole big mess of ooze and we drop it down. Because we have lots of different biomes, we want to have an even distribution of those. So what we do is we work out how many points we're going to have. And then based upon those weightings of each biome, we fill up our inventory. We fill up our set of, here are the set of seed points. We're going to put in 50 seed points for this biome and 50 for this other biome. So we fill that up. so that we can then randomly pick ones. Because we don't want to just apply one biome, then the next, then the next, because that then means the biomes that are applied later have a higher priority than the ones before. They're going to be able to overwrite them, which is not the behavior that we're after with this. So we randomly pick ones. When we spawn those biomes, then we have this idea of a working list. So we put data into it, into our queue, and then as we go through, we keep track of where we've visited. So we never visit an area twice. We're using approaches that you would see in pathfinding, actually. We never visit an area twice. To easily search through the neighbors, we just set up a predefined set of here are all of the offsets for them. As soon as we've visited a neighbor, we flag them as such so we don't actually ever visit that again. We then do this decay process. So the decay is random, and we apply that decaying every time. As soon as that strength gets too low, we no longer actually continue expanding that area. And then at the end of it, we save out an image so that we can just test and see, okay, how is this actually working? Is it giving us the results we're after? So this is the first part. In the second part, we're going to take a look at taking a low-resolution biome map and generating a high-resolution biome map from that, and then starting to manipulate the terrain from that point forward. Thanks, folks. That is all for this video. If you're looking for the project, you'll be able to find it up on GitHub, and I've put a link to that in the description below. If you've got any feedback, any questions, please chuck in a comment. And if you're looking to find ways to support the channel, chucking in a like or subscribing to the channel is always a big help. If you're looking to go further than that, then I do have a Patreon set up, and any support there is super appreciated. And there's a bunch of different things that you'll get as part of being a patron there. And the big thing is it's going to help me make more cool things like this, which is going to help more people like yourself to be making more games, which is awesome. And that is all for now. Thank you.